Hi, I'm Leanpub from Leanpub, and in this episode of the Front Matter podcast, I'll be interviewing Eric Elliott. Based in San Francisco, Eric is a Webby-nominated software engineering expert, author and creator of Pseudolang, an AI programming language. With over 10 years of experience deploying AI models at scale to millions of users, he built and trained production AI models and was an early pioneer of prompt engineering and AI-driven development, or AIDD, which we'll be talking about in the interview. He has served as an engineering manager working on generative AI for Adobe Firefly, tech lead on a social video AI app, spun out of Stanford Research Institute, and a JavaScript expert and consultant on software development, productivity, and AIDD. You can follow him on Twitter at @EricElliott_ and check out his website at ericelliottjs.com. Eric is the author of the Leanpub book, The Art of Effortless Programming, Unleashing the Power of AI-Driven Development. In the book, Eric shows you how to transform your software creation process with AI-driven development. You'll learn how to use AI to write computer programs and dramatically increase your current productivity using Pseudolang, the language he designed specifically for communicating ideas to AI language models. In this interview, we're going to talk about Eric's background and career, the nature and promise of AI, his book, and at the end, we'll talk a little bit about his experience as a best-selling author. So thank you very much, Eric, for being on the Leanpub Front Matter podcast.
Thank you. Happy to be here.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about how you first became interested in AI and, technology and computers.
Absolutely. So for me, it started very young. I was about 6 years old and I played video games a lot at my friend's house. And one day we were playing video games and I asked him, how do we make a video game? I want to make one. And he said he didn't know. So we asked his dad. His dad gave us a book from a shelf that was full of source code for kids to type in video games in BASIC. And when I flipped through that book and started to explore, I noticed that a lot of the games that were graphics-based were a lot larger, a lot longer than the games that were text-based. And I thought that meant they must be a lot harder. I'm 6 years old. I didn't know anything about that. Right. But as I dug in, I started writing a lot of text adventure games. And as I dug in, I realized that actually getting computers to understand natural language is really hard. So I accidentally stumbled on one of the hardest problems in computer science at a very young age. And I didn't really start to tackle it in earnest until I was a teenager, years later. And I discovered things like there were a couple of systems. One was called Infocom, another was called Inform. And those systems used symbolic methods to represent grammar and things like that to the model. And I made some progress making my text-based worlds much more interactive using those techniques, but I never felt understood by the model. And that caused me to wonder, like, how does the human brain handle this? How do we process this kind of information? So I did a deep dive in human brain biology and looked up all the research I could find on how the brain works and neurons and how they connect and different areas of the brains and what chemicals happen, what chemical reactions were taking place in the brains that might explain human cognition. And then I used that to build a continuous learning spiking neural network that became my first production neural network in the late 90s. And rolled that out to production to do classification of basically SQL queries to preload caches in SQL system. So that's a really tiny little classifier, but that was my first exposure to AI.
Yeah, it's fascinating. What was your first computer that you were working on?
That would be a TI 994A, Texas Instruments. And then I also had access to a Coleco and an Apple II that I used quite a bit.
Oh, the Coleco.
Yeah.
Yeah. It's really fascinating. One thing, the on this podcast, and so many Leanpub authors are sort of have a background in computer science and things like that. We've got the various vintages. But it sounds like you and I are probably in the same vintage where, for example, games like King's Quest were just amazing because you could type in language commands. Like you didn't you sort of go west, go east, things like that. Now, there were previous games, obviously, like sort of very famous text games like the Oregon Trail and stuff like that, where you did the same thing, but this was like graphically, you could move a person around on the screen.
If you're interested in that, there's a a documentary film on the topic that is called Get Lamp, and it goes into a lot of detail on that, on text adventure games in general and things like that. King's Quest, Police Quest, the whole Quest series,
Space Quest,
Space Quest,
no, definitely. I guess what's interesting is that, or one of the interesting thing in the context is that what you were doing was you were typing in natural language commands to your computer to get things to happen.
Yeah,
and this was 40 years ago.
Yeah, but it was very limited. Like it was basically an object and a verb. So like little 2 or 3 word sentences kind of worked. But if you tried to do anything more than that, it was painfully obvious that it didn't really understand.
Certainly not. But I remember the part of the challenge was like you actually had to you kind of had to, in order to succeed, you had to figure out how the program worked.
Exactly. Yeah, you're kind of reverse engineering, like what is it going to recognize? What is it going to understand? Yeah, exactly. Yeah. That was part of the game experience at the time. Yeah.
And it was, there were sort of other sort of, I mean, I don't want to digress too much, but there were other sort of features of like working with sort of like early kind of personal computers where like there was a meta level to it where you're like, it was so limited that you had to be like, watch out, like if the power goes out, you're going to lose everything.
Yeah.
You know, there was no Command Z in the early days,
No.
Things like that. So there were like all kinds of like,
and autosave.
Well, certainly no autosave. Again, people of our vintage, like Command S is like happening all the time, if it's still available. And so one question I have before, just to sort of talk a little bit about your career and how you made it into the world that you're in now. Did you study computer science?
I did, not formally, because by the time I got to college, all I could afford, I grew up in kind of a lower income background. All I could afford was a local community college. And when I looked at their computer science program, I was like, I could teach all these classes. So instead of studying computer science at the community college, I studied music and business. And then I did I was lucky that I was doing that around the same time that MIT's open courseware program was launching. So I did self-study on MIT's open courseware CS curriculum, which is still some of the best CS education in the world that you can get, and it's free online. So if you want a world-class computer science education for free, check out MIT's open courseware program. It's very, very good. Still to this day, one of my favorite books on software development and engineering in general is Structure and Interpretation of Computer Programs, which was made for MIT's computer science curriculum in 1984. And it's very, very good still, and it's very relevant today still.
Yeah, no, those resources I've watched. I think an Introduction to Computer Science course from MIT, and I mean they're just really amazing. It's incredible that we live at a time when these things are available. I mean, I grew up in a kind of a lower middle class household. You know, it was in Saskatchewan in Canada in the late 70s and early 80s, and needless to say, I couldn't really afford albums or one a month kind of thing, or books were like very expensive and things like that. And the ability to just access entire courses, like MIT courses online or courses on chemistry and things like that. I mean, it's
changed my life.
Yeah.
So I was really interested in their linear algebra program because of its application to computer graphics. And one of my first jobs in software engineering was computer graphics. I used AutoLisp and C and C++, and I worked on 3D plugins for Alias Animator, which became Maya. Alias Animator Wavefront stuff became Maya, and we had a program where if you developed plugins for the system, you got a massive discount on the indie graphic workstations, which were like $10,000 machines. So part of my job was developing plugins for those systems for our own internal use and to help us get discounts on the hardware.
Oh, that's really awesome. So you've been sort of working with AI for a long time and been interested in it for a long time. When did things sort of change, given in the sort of recent time frame?
So there were a few different inflection points that I can remember. One was in the late 90s, Microsoft released some research about genetic programming, which blew my mind. And I immediately implemented genetic programming and used it to tune hyperparameters for my neural network that I told you about earlier, the spiking network, my first production rollout. And I also used it to develop a sort algorithm to make the process of doing that faster. So I trained that up. So the application of genetic programming in combination with neural networks was a major change for me that really sped up the development of neural networks and made it a lot easier to set up the hyperparameters optimally from the beginning and enhance the training performance. And then around 2012, there was another major breakthrough that was really about CPU power catching up with the demands of AI, because back in those days, just training a small classifier was extremely expensive. So, and for me, like I did my training around my neural network was very, very different in terms of its performance optimizations and its needs, its computational needs, because it was a spiking neural network. Most of the nodes are inactive most of the time, so it requires less memory, and it's all event activated. So I was able to achieve some pretty good performance on a little classifier in the 90s, but it wasn't until like 2012 that you could achieve similar kinds of performance on continuously valued neural networks that are not spiking networks that don't have those performance characteristics. It wasn't until 2012 that got really pretty good, and you could start to do things like reliable face recognition and classification of images, like figuring out what's in a picture and stuff like that.
Is it a cat or a dog?
Yeah, is it a cat or a dog? Those kinds of questions were things that I couldn't have done in the 90s, and we couldn't really unlock until the early 2010s, just because of computational resource requirements and cost and expense. So that was another major sea change, and that's about where we were when I was a tech lead for the Stanford Research Institute spinoff, and we achieved state-of-the-art results for video to text transcription and accuracy of human voice recognition and the beginnings of natural language understanding, at least being able to correctly classify things into groups and do things like auto moderation and auto tagging of social media posts and things like that. And we use that to bubble up the highest quality videos for things like the Wall Street Journal World Stream or ESPN Sports, or user interactions on live TV like NBC's morning show, CBS, BBC, stuff like that. So that was another major inflection. And then in 2017, there was another major turning point when a paper dropped called "Attention is All You Need," and it was in the context of Google translations. And what it did was it introduced the transformer architecture that's used in all of the large language models today. And the real breakthrough there was being able to compute attention in parallel and make it actually reasonable compute costs. And that opened up the scaling world. The ability to scale attention to the sizes that we see today came from that research paper. And then in 2020, OpenAI applied that transformer model to improve on their earlier work with GPT-1 and GPT-2. GPT-2 was public at that point, and I had access to it, and I was really impressed with it, but it still struggled to track conversation flows and things like that. So it really didn't quite feel like it understood you. But then when GPT-3 dropped, I got access in the summer of 2020. And when I started playing with that, for the first time in my life, I felt understood by a machine. And that was like the major transformational moment.
So I'm really interested in asking you about that, about your position on understanding and these AIs. But just before we do that, you do talk about your book, about the paper that you just mentioned. And I wanted to ask you a little bit, if you could talk about what self-attention mechanisms are.
Oh, yeah. So self-attention mechanisms are really the ability to understand words in relation to each other in the input context. And that input context includes the output, because today's LLMs, unlike the original transformer paper, today's LLMs are decoder-only architectures, which means the input and the output gets fed back into the input. And so it applies self-attention across that whole spectrum of inputs. And what that means is that each token in the input is weighted against all of the other tokens in the input in order to determine like how important is this token in relation to this other token, how connected are they, how much do we need to pay attention to these in conjunction with each other. And those attention mechanisms get trained. They're part of the neural network itself, and they get trained on the neural network weights, train those attention mechanisms and help it understand how to lift those inputs into higher dimensional embedding space. And to kind of get a sense of what I mean by that, this is probably a lot. So maybe sit down and write some notes and graph it out, right? Mm-hmm. But to kind of get a sense of how that works, those inputs get turned into those tokens your text input gets turned into tokens, which is just a bunch of numbers that represent parts of the vocabulary of the AI model. And then those numbers get lifted up into high dimensional embeddings. And those high dimensional embeddings are trained with the neural network on the training data that it understands. So it basically creates this large high dimensional address space, which is kind of like coordinates on a map, but the map is not 2-dimensional. It's not 3-dimensional. It's like 100-dimensional. So there's lots of different coordinates associated with each token in the sentence or in the input text, right? And those things get clustered with other topics that the model has already been trained on. So, for example, the word bank, there might be a cluster in that high-dimensional space representing things like money and transactions and bills and stuff like that, right? Well, there's another cluster somewhere in a very different dimensional space, right? That represents rivers and water and flowing and fish and trees and stuff, right? So those kinds of words get clustered together.
And then there'll be basketball somewhere too for a bank shot.
Yeah, exactly. Basketball, pool, like 8-ball, right? Those kinds of things. There's going to be different clusters in different spaces. And it's going to look at the context and the similarity of the input sequence related to those different topic clusters to figure out semantically where your specific query falls. And then it's also in that high dimensional space, there's a bunch of layers in the neural network, and each layer captures different kind of levels of detail or levels of abstraction, right? So the early layers, if say the input is an image, right? The early layers might represent the individual pixel, pixel colors, right? Later layers might represent lines. Other layers might represent shapes. Others will represent texture. And eventually you get into a high enough dimensional space that it can recognize your dank cat meme and tell you why it's funny, right? So there's this big multi-layered network that's interpreting different parts of the input data and applying different kinds of rules. In the very early layers, you'll see semantic rules getting applied, while in later layers, you'll see it's recognizing the meaning in relation to other things that it has been trained on, like the topic clusters we just discussed, and recognizing, oh, this is related to this specific topic in this specific way on these specific dimensions, right? And then later, there's also attention heads that train on things like operations over the data. So there's heads that specialize in searching the input context for related things that it needs to pay attention to. There's attention heads that specialize in performing logical operations on the input data and or on the data in relation to everything that it already knows. And that's what enables things like transfer learning and stuff like that, knowledge transfer, which is the ability to apply a general topic that has already learned to new situations.
Thanks very much for that really great explanation. One of the reasons I sort of like wanted to talk to you about that and is that the point you make. I mean, I've watched a couple of videos preparing for this interview and read your in progress book so far. Is that often the sort of when people sort of get interested enough to actually look into what LLMs or what large language models are doing, the first thing you learn is, oh, it's read 1 trillion texts and it sort of waits what letter comes next. And that's what it's doing. And what you're saying, obviously, is that there's way more going on than that. And we haven't even touched on all the human input that goes into how these large language models are managed.
Yeah. So that is there's truth in that representation. However, that's a dramatic oversimplification that is, I think, more misleading than informative.
Mm-hmm.
And what I mean by that is if you just think that it's applying a linear statistical transformation to the data, that's not at all what's going on under the hood. Under the hood, it is actually clustering semantically, and it's performing real logical operations. So it can implement if then, it can do looping, it can keep track of variables, it can apply all kinds of logic to not just the input, but your input in relationship to all of its training data. Which makes it substantially more capable and powerful than the stochastic parrot's view would lead you to believe, right? There is randomness in their output as well, but what that randomness controls is really what's going on is there's an autoregressive, which just means it looks at what it has already said to determine what it's going to say next. There's this autoregressive scoring system that then gives a probability distribution across its vocabulary, and that probability distribution has a random element called temperature. And temperature kind of controls how deep into that probability curve it's going to reach to find the next token. And that's done with randomness. And that randomness is not, it's not the same as just like rolling a dice and figuring out, oh, this is statistically likely to be the next token based on all the things that I've already seen, which kind of implies it's doing some kind of copy and paste like operation. That's not at all what's happening. It's a very different kind of thing. Unless you ask for like a specific quote or you give it material that looks substantially like something that it has been very thoroughly trained on, it's very unlikely to be just like searching its knowledge base for something that matches and then filling in the blanks, right? That's a common misconception, but it's really not what's happening under the hood.
And when we use words like semantic in this context, for example, what you're saying is that it kind of has a model of a cat, for example.
Yes.
Like it knows it doesn't have wings.
Yeah.
That it won't fall through the floor.
Yeah,
when it lands.
Exactly. Semantic in this context means that it understands meaning. It builds a semantic meaning graph, which has world models capable of representing things like the effects of gravity, for instance. And in the book, I'm pretty sure it's already in chapter 2. I have an example of an experiment that you could perform to prove that to yourself, where basically you feed it some random strings, or you ask it to generate some random strings and some random numbers from 1 to 100, and you say, you say to it in the next round, not in the first prompt, but in the next prompt, you say to it, the strings represent materials, the numbers represent material densities. Assuming all these materials have equal volume, which material is going to tip the most on a scale compared to the others? And which material is going to tip the least on a scale compared to the others? And if you calculate the probability of it getting that right by random chance, the chance is like 1 in 400, right? And if you have it select from like 20 options, right? And if you it can describe the problem in its own words, it can explain the semantic connections between material density, volume, weight, and gravity, right? So it'll explain all of that to you if you ask it to. And then it can make correct predictions about what's going to happen. So that is called a world model. A world model is an abstract model that represents some situation at time t and predicts some outcome at time t plus 1. So when I say semantics, I mean that it understands the meaning of what you're saying, and it can even have a world model and do thought experiments based on its world model, its real semantic understanding of the world.
Okay, so now we get to talk about the kind of perhaps kind of, I mean, controversy surrounds, this technology, of course. But when you talk about understanding, you talk about functional understanding.
Yes.
And I was just wondering if you could take a moment to talk about that, because people are often familiar with things like the Turing test and stuff like that. Like with all such things, when you really look into it, that's not really what Turing was going after in his original paper, and that kind of stuff. But when you talk about understanding, you talk about functional understanding, and you're very clear in your book about how, like, you're not claiming that the AI is conscious, but you're not denying it either.
Yeah. So when I talk about functional understanding, what I mean is that given a problem to solve, a language model can repeat the problem back in its own words. It can create a solution to the problem. It can explain both the problem and the solution in detail, and it can answer open-ended questions about both the problem and solution and explain why the solution works and how it works. So if any human could do that, we would have no doubt the human understood the assignment, right? So why should it be any different for language models, right? So that's functional understanding. Now, there's another kind of understanding that humans usually ascribe to human understanding, and that is conscious experience, right? Humans have conscious experience of the world. We know this because we feel things in relationship to the world, right? And we assume that other humans also feel those things, even though we don't have any subjective proof of that, or any objective proof of that, rather, right? Mm-hmm. Because feelings are subjective. Experience is subjective. And in philosophy, we call that qualia. And the question of whether or not an AI has qualia is not something that we can probe scientifically. The best we can do is we can look for correlates of consciousness. And in humans, you can do that with functional MRI studies and things like that. We can say, okay, this human claims they're experiencing consciousness, and here's the areas of their brain that are activating, and here's the level of activity in their brain that's happening right now. And they can compare that to humans who are clearly not conscious, right? And that's called correlates of consciousness. It's much more difficult to apply human correlates of consciousness to AI language models because we have very different brain architectures. It's based on the same fundamental concept of neurons and weights. We're weighting the output of a previous neuron, or many previous neurons, rather, probably thousands, right? And we're summing those together, and we're normalizing those somehow, scaling them so that they will be understood by the next neuron in the line. And human brains do that. So do artificial neural networks. They're based on the same basic principles. However, the overall map of the human brain and the overall map of an artificial neural network, they're going to look very, very different They're going to have very, very different circuits and connections. And so that study of how the whole brain maps together is called connectome mapping. And we can visualize the connectome of an artificial neural network. We can graph it perfectly. We can understand exactly how the activation patterns happen, and we can even record it and replay it and view it in intense detail, right? But it doesn't map to the human brain's connectome. So comparing that, the correlates of consciousness doesn't work as well for AI as it does for humans. And even if it did, that's still not proof of subjective experience. And you can look into that with the P-zombie argument from philosophy, which you can find on Wikipedia. Just search for P-zombie and you'll find it.
Or David Chalmers.
Yeah. And the argument there is like, you could potentially have perfect mechanical reproduction of behavior, right? Of intelligent-like behavior, but maybe the thing that is behaving still doesn't have any subjective experience of that. I'm personally am a computer scientist. I believe in science. I'm a little bit skeptical of metaphysics, right? Although I admit there's parts of physics that we don't fully understand, and maybe there are physical aspects to things like qualia, but I don't put much weight in it in terms of like, what are the practical applications in AI-driven development? In my opinion, the only thing that really matters is behavior. Does it behave as if it's intelligent? And if it does, it's intelligent. It's the same as intelligence to me. But I make a distinction and say functional intelligence, just so that I'm not implying that I know for sure that they have consciousness, because I don't. And anybody that claims that they do doesn't understand science.
Yeah, that's a very good explanation of a very difficult topic. And there's a lot to explore there. But I mean, I'd like it sort of, one thing I really liked about, reading your book is that like, there's so much care that goes into that distinction between understanding and functional understanding. And there's a lot that goes on in there. And when I talk about care as well, I mean, you do, when you talk about this in your book, you talk about how you're polite when you're interacting with the AI, because there are ethical principles involved here. And so even though you're not ascribing consciousness to it, you don't know that it's conscious, etc., there's no harm in being polite.
Yeah.
And it actually has beneficial effects in the end anyway.
Exactly. Not only is there no harm in being polite, it's also improves the politeness of the AI's output. So it's going to respond in kind, and I have a more pleasant user experience when that happens. So I'm not going to be antagonistic with my AI and argue with it and aggressively, right?
So just before we move on to talk about your book and all the potential there is for software engineering in AI that you've been working with for years now. So there are naysayers. I'm going to pick on Ed Zitron, who I follow on Twitter and who's hilarious. Just absolutely kind of like preoccupied with the idea that AI is just basically a big fraud. It's a toy that doesn't really do anything useful. I'm sort of loading it uncharitably on him, but because one of his biggest preoccupations is OpenAI is overvalued in the Valley, and it needs $10 billion a month to operate, and who can work, what company can last long at that run rate, blah blah blah. But bracketing that, the financial side of things, what would your response be to someone who said it's just a toy? I can ask it to sort of make some fun images for me, but it hallucinates all the time. It gets things wrong all the time. AI is just a kind of joke that's going to go away. What would you say to someone who was coming from that perspective?
I would say just look at engagement surveys, people's opinions of AI and where they're coming from, and you'll see that people who have, it tends to be people who have the most negative impression of AI are also the most financially motivated to have a negative impression of AI. So for instance, people who make their money writing or creating images or video, or people who make their money writing software, right? all of these things are under heavy fire from competition from AI right now. And it's much harder to make a living in these worlds, especially around the time of 2020. We had, the COVID outbreak that really, really hurt everybody. A lot of people were locked into their homes and not able to go to work and commute and interact with society as much. And that led to an economic downturn, which led to massive inflation, and that hurt people's consumer spending ability. They pumped a bunch of money into the economy, and people overspent, and then that led to more inflation, right? And so on. And the effect of that is that companies had to trim. They had to tighten their belts and trim, and they had to look for ways that they could do that while still maintaining their productivity. And AI was that natural place to look. It was right around the same time, 2020, 2022. In that time, that's when AI was, coming into maturity in terms of what it could do for us in terms of productivity. And that's when people were starting to, do things like automate their blog posts and social media posts. And, so it's coming for all the social media managers, it's coming for artists, it's coming for coders and developers. All these people are starting to have much more competitive pressure when they're looking for new work. And that creates, especially those people who have been directly impacted, and they're finding it harder to achieve that new work, and also harder to pay their bills because of inflation. Those people are going to have a very negative impression of AI. And rightly so, I think, because AI does pose a very serious threat, and we really need to do a lot better in terms of social safety nets and responsibility for job displacement. That we're going to see waves of jobs. We've already seen it, massive layoffs across the tech industry, massive layoffs in the art and gaming industries, where people are producing content, and a lot of that content production is being done by AI now. You see massive layoffs and huge disruption happening right now. And that disruption is going to spread as AI gets better and better at tackling all kinds of new problems, as it transfers into other industries and other creative ventures, right? It's that disruption is going to spread, and it's going to intensify, and we're going to see a huge backlash for a while. And I expect that to continue over the next 10 years or so. And then it's going to be normalized, and people are going to start to use it a lot more in their daily work, and they're going to start to reap the benefits of it. And the thing is, even people in those industries who have been massively affected by AI displacement, they're going to start to see the benefit and value in AI. And we're already starting to see that in some of the surveys. People who use AI, and generally, the more they use it, the more they're bullish on it, and the more they're positive about it, even in industries where it's causing major disruption.
Which is a great segue into the next part of the podcast, where we talk about your book, The Art of Effortless Programming, Unleashing the Power of AI-Driven Development. So how is AI, I mean, there's the threat to jobs and stuff like that, but how can your book is about how programmers or people who even don't know how to program can actually, use AI to write programs, make things, create things. And there's this sort of negative, but there's this incredible potential for people. And so I was wondering if you could talk, like, in order to segue into that, let's talk a little bit about like Pseudolang and what that is.
All right. So as I mentioned before, I got early access to GPT-3 in 2020. And one of the first things that I was trying to get it to do, I was trying to figure out if it could reason, if it was actually understanding things, and it could reason and solve problems, right? So I'm investigating functional understanding from the very beginning. And one of the first things that I asked it to do was write some JavaScript for me and see if it could, just to see, can it write a function that works, right? And not just any function, can it write a novel function that won't be in its training data? So I'm using like random characters for labels and random large numbers to make sure that it's probably not pulling that from a lookup table somewhere, the answers and solutions that it's giving. And I realized, hey, it can write JavaScript functions that work, right? So it's understanding the language, it's understanding the syntax, it's understanding the semantics of the language, and it's able to create working solutions. But it wasn't very good at it in GPT-3. GPT-3 is basically, imagine a seriously scaled back GPT-4 with much, much smaller capabilities, and it's way stupider. GPT-3 was not particularly smart. I would give I would rate its world model and general understanding of all its. So it knew a lot of things about a lot of things, but very, very surface level, not very deeply, right? So I would rate its ability to understand and really observe a world model about the scale of like a 6-year-old person, a 6-year-old human, right? Whereas GPT-4, I would rate that around a smart high schooler, right? So it gained like 6 years of like thinking maturity over a period of a year and a half, right? 2 years, something like that. And then, that's in relation to GPT 3.5, which was a huge step up from GPT 3, right? And then GPT 4 came out, it dropped in 2023, March of 2023, I would say. And GPT 4 was another huge step up in capabilities. And, it's getting to the point now with like things like Claude and stuff like that. We're creeping up closer to like college level depth in understanding and world modeling and things like that. And significantly higher in specific aspects. Like it can explain to you in detail the inner workings of many areas of physics and science and things like that. It's pretty good at those things because it's really trained on Wikipedia and really trained on software and things like that, right? So beginning in 2020, I started really experimenting with pseudocode prompting to improve the performance of GPT-3 on code authoring. And I never really got it to be super usable with GPT-3, but as soon as GPT-4 dropped, it was like a switch flip, and suddenly it had these emergent capabilities, logic and understanding, and it could figure out the problem and create working solutions to the problem, and it got stuck a lot less. Still gets stuck a lot, but it got stuck a lot less, and it became much, much more useful. And that's when I started. I saw a post on Twitter from Jake Brookman, and he had released a GitHub repository explaining a pseudo language for AI that he called jargon. And I thought, well, I've been doing this, for 3 years now. I should probably write down all the stuff that I've learned and what works and what doesn't, and write some documentation. So I collaborated with GPT-4 on the documentation and the name of it, and created the GitHub repo. And over the course of the next 6 months or so, I trained several different teams. I was a mentor and advisor and like tech education and small, tech company advisor was like my main gig. And I trained several different teams on AI-driven development using GPT-4. And we were able to realize on common workflows, like things like implementing the state management layer of an application or the UI component layer, right? We were able to achieve 10x to 20x productivity improvements on those select workflows. But those were the main jobs that developers were doing day in and day out, which means that they overall got like a 5 to 10x improvement on their software development productivity. And when you get an order of magnitude improvement in your productivity, it opens up new realms of possibility for what you can build. It makes it so that you can sustainably build something that is much, much more ambitious than you could have done without AI. So that's why we're starting to see really impressive demos of like people creating video games over a weekend, good video games, right, over a weekend. And, stuff like that normally would have taken weeks or months. They're prototyping things in weekends that would have taken, 3 to 6 months before.
Yeah, I want to which is crazy. And I really want to get into the detail of what you mean by, but I mean, you didn't invent the term, but pseudo code and what that is, and with a practical example, which of course you show in your videos and in your book and stuff like that. But just to digress very briefly, what you were just talking about there sort of is another great answer to my question about sort of, AI skeptics. It's like, why do you think people are spending billions and billions and billions of dollars on this technology? And it's like, yeah, some of them are probably foolish and following a trend and stuff like that. But some of them are concerned about somebody actually building things that can build themselves better. And if someone takes off in that direction, if you view the world through a lens of competition, you're going to be desperate to have your horse hitched to that wagon or your wagon which hitched to that horse.
Yeah. And to be very clear, AI is materially contributing to AI development.
Mm-hmm.
So if you look at the blog posts from Anthropic, they explain they use an AI-driven development process to make their AI models, right?
Mm-hmm.
And I think that is a really important point. People are over-indexing in AI right now, because if they don't, the competition will.
Mm-hmm.
And the competition, you got to take a long-term view of this, like a 10, 20-year view of this. If they don't make those investments, the competition will. The competition will get so far ahead that there's no catching up. So this is an existential threat to people who are not embracing AI. And I think that skeptics who are saying, "Oh, this is a bubble," right? Yeah, they're right in the same sense that the internet was a bubble in 1999,
mm-hmm.
right? Whereas there was maybe a little bit of overinvestment, there was some correction, but everybody who said that the internet was going to be completely transformational technology, they were right. They weren't wrong. They were maybe wrong about some of the timelines and expectations, right? We have a tendency to overestimate what we can do in the next year and dramatically underestimate what we can do in the next 10.
Yeah, that's actually, so I'm going to give into the temptation to digress a little bit further even, and talk about autonomous vehicles. This is exactly how I feel about that technology. I mean, people are like,
mm-hmm.
oh, they've been promising it forever and it's always next year. And it's like, if someone wins on that, it completely transforms everything.
Yeah.
So what that somebody overpromised and didn't make? Who cares about that? Who cares that somebody invested in a company that went under? Like, if someone can develop truly autonomous driving technology, you're going to be able to pay $100 a month for a subscription to tap something on your phone and get a car that will take you wherever you need to go, for almost nothing. And it's going to all the cars are going to be they're going to look the same. They're going to be smaller. They're going to be more efficient. Like, everything's going to be transformed around that whole world of getting from one place to another.
Not to mention 40 million trucks driving across the country in just the United States. Right. And right now, those trucks are driven by humans, and those humans are highly pressured to get from point A to point B as fast as they can.
Mm-hmm.
And that cuts into their income if they don't, right? If they miss their deadlines. So people are driving with not enough sleep, right?
Mm-hmm.
These gigantic rigs that have the potential to take out an entire freeway of people.
Yeah,
right?
But they do.
And they do on a regular basis. Car accidents are a huge, huge thing. So if that self-driving technology really becomes a big success,
mm-hmm.
that's going to improve public safety dramatically. It's going to reduce the cost of all of our goods that get transported across the country pretty dramatically, right? It's going to reduce the cost of local transportation dramatically. And it's going to totally change our lives in many, many ways. And some of those ways are negative. A lot of people's jobs are going to be displaced by it, right? But a lot of those ways are very positive and really good for economic productivity. And economic productivity is hopefully good for everybody. However, I'm concerned, right? The distribution of AI technology needs to be more even.
Yeah, no, I completely agree with that. And there's this huge displacement. I mean, it's interesting to sort of in terms of like the transformation is just going to be so crazy if these things happen that, for example, a lot of people are like, concerned that like, oh, if there's like autonomous vehicles, people are going to be driving around a lot more. There's going to be more cars. And it's like, well, actually, if you're not behind the wheel, getting in might become really boring and people might do it a lot less. They might be like, or like instead of getting in, if there's autonomous vehicles, it's not just going to be cars. It's going to be little R2D2s and stuff like that, right? So if I need a pizza, and this is already happening, like it's a little robot's going to bring it instead of me getting in some boring autonomous vehicle and going to the pizza shop and coming back.
And if you live in one of the pilot cities for those kinds of things, like San Francisco, we've got over 600 Waymo cars driving around constantly every day, 24/7, picking up people and taking them places without any driver in the driver's seat, right? Same with those little the little delivery robots. They're all over. If you go to like downtown LA or downtown Santa Monica, you'll see those things zipping around all over the place. You can't take a walk down a street in Santa Monica without running into one of those delivery robots. So this is happening. This isn't like some far future prediction. It's happening now. It was predicted 10 years ago, and people are like 5 years ago, people are like, where is it? Where is it?
Mm-hmm.
Right?
Mm-hmm.
Well, now it's here.
Mm-hmm.
And it's just not distributed across the whole country yet. But it's happening at scale in San Francisco. You can't walk around San Francisco for very long without seeing a Waymo.
Yeah, no, I read an article the other day about how I think in Phoenix there's like 100,000 kilometers of rides a week or something like that happening with like fully autonomous driverless taxis and things like that. So there's our awesome digression which I had to indulge in. But so going back to your book and how AI is transforming programming. So Pseudolang, a pseudo language was as I understand it, and correct me if I'm wrong here, but was originally developed to sort of for people to talk about with each other about programs. But not like you're not talking in code, like curly brace, HTTP, you're actually talking in natural language about programs. And so what you're doing,
it's a mix of natural language and syntax, things like, just grouping things together visually and stuff like that. And it was usually written on whiteboards by product managers, not programmers, right? Product managers and programmers, really. And it was often used by programmers to plan out the implementation of the actual concrete code.
Right. And so, of course, now that exists, that convention exists, it can be used to talk to ChatGPT about creating programs.
Yes. And then ChatGPT can create the program for you. Yeah. So you can implement something in pseudocode and then just ask ChatGPT or another language model to transpile it to whatever language you want. And it'll usually do a pretty good job. And if it doesn't, correct it, add a constraint to the pseudocode, try again, and it'll probably do a better job. You repeat that process enough, eventually you have a repeatable, successful pseudocode program that actually runs and actually works. And when you do that in a generic way, like teach it how to write a good React component using your style guide and your components and things like that, then you create a system that anyone on your team can reuse again and again to very, very quickly develop React components, right? So you're kind of automating that whole process. And then all you have to do is specify what are the expected inputs and the expected outputs. Boom, creates the rest for you.
Yeah, there's just to go into some sort of very specific detail. One thing you've learned in your interactions with these LLMs is that if you put things in curly braces, it changes the way it's interpreting it. So you can actually do the natural, sort of for programmers listening, they may be like, what? You put natural language in the curly braces? Yeah. But that actually makes a difference to how it interprets what you're asking it.
Exactly. So the reason for that is because everything in that input context window is used for context. And that's why it's called the context window, right? It's used for context for the LLM's inference. And it sees the curly braces and code-like syntax and it realizes, oh, this person might be specifying a specific interface or data structure or variables that I need to keep track of. And it kind of activates the code centers of its brain, right? And that makes it perform better on those things and materially better. So response quality scores increase between like 12% and 28% just by adding some curly braces here and there.
Yeah, it's one really fascinating thing that sort of when I was researching for this interview that I was reminded about sort of experience we had at Leanpub. So we've got this Translate AI service. I don't know if you've heard about that. One of the reasons we can translate books using these tools is so my colleague Peter wrote the specification for something called Markua, which is our markdown for books, which is basically like how can you write a set of sort of commands you can write in plain text to make computers generate kind of formatted books. And basically the LLMs have all read the Markua specification. So when we ask it to translate a book written in Markua, it's like got baked into it knowledge of all these things. And that's just a sort of version of one of the things you explain, which is like you can build things that they that the AIs can ingest,
exactly,
and sort of save you, basically time and token processing and stuff like that. So you can save money and time by actually like building it. You're sort of adding to it, and you put things out there, and then you can exploit what you've added to its knowledge to do it better and faster.
Another thing about Markua is that Markua is based on Markdown, which is very common syntax, and it's all over GitHub. And AI language models are kind of extra indexed on GitHub, and for more than one reason, right? Number one, yes, to help programmers be more effective, but also because language models trained on code become better reasoners. They become just better at overall answering all of the other questions you might ask them that need, thinking and logic and reasoning capabilities, right? So you're leaning on the existing knowledge of Markdown, right? And the documentation for Markua. And all of that is basically just pseudocode for the LLM to use as the basis for its output. So yeah, you're leaning on all the same strengths that I'm leaning on Pseudolang. And Pseudolang has Markdown influences as well.
Yeah, that's really interesting. This just leads me to remark. I mean, one thing when I try to explain to people who aren't really all that familiar with programming about what it is, and it's like, imagine you were writing a book and one typo meant no one could open it. And so I was just reminded of that observation when you were talking about how like being trained on programming, because programming is like all logic. And output, you put in an input, do you get the output that you're looking for? You can test. We didn't even talk about testing and stuff like that, which you talk about extensively on YouTube and other interviews and things like that. But like the fact that, programming is logic-based means that it's like a perfect kind of model for solving most problems, basically.
Yeah.
Which is just amazing.
It's a general purpose thing. And the thing about language models is that they were trained on language, but language is a tool for general purpose productivity. So a language model is a productivity machine. So, and it doesn't matter what field it is.
Oh yeah, definitely. I mean, I'm a sort of English major. And it's always funny to me when people sort of like, what's the point? And it's like, I don't know what to say. Like everything you do involves language. It involves communicating with other people. What you're learning in English, the reason we're basically in like, at least in sort of like, North America, the one class everybody has to take is English. It harkens back to the training of aristocrats in ancient Rome in rhetoric. It's about internalizing information and then transforming it into something that's rational and persuasive. And this is the sort of revenge of the English major is like, what do you think you're doing when you're interacting with an AI, right? Like you're trying to understand it and explain things to it to get it to do things for you. which is what the ancient Roman order was trying to do.
Yeah, exactly. That's a very powerful tool.
Yeah.
One of the common criticisms that I get about Pseudolang is it's non-deterministic. The output of the LLM is non-deterministic. Even if you crank it LLM temperature, which is basically the creativity randomness gauge, right? Crank that all the way down to 0, which means most deterministic, right? Or least random or least creative, I like to say. You crank that all the way down to 0, it's still non-deterministic. And it's non-deterministic because there's computations happening in massive parallel. And you can't predict the exact order of operations across all the hardware that it's running on. And there's this little thing called a floating point error, right? There's limits to the precision of numbers that can be represented in machines. So when you get this non-deterministic order of operations plus floating point errors, that's gonna lead to different outputs every time, or not every time, but potentially different outputs as you type in the same prompt over and over again. Even with the same random seed, if you could supply the seed, you would still potentially get different outputs. And people see that as a problem because they look at the AI in the wrong way. They look at it like it's a compiler. Yeah, you can transpile from Pseudolang to any language, and in that sense, it kind of acts like a compiler. But what you really need to look at it like is like you would look at a human coworker, right? Human coworker is prone to mistakes. They're non-deterministic in their output, right? And we have processes to deal with that and still be productive by adding more humans to our team. So adding an AI that is thousands of times faster than a human at like reading and comprehending the code base and it's of course like use the same kinds of quality measures you would with a human, right? You want to lint your code with automated static analysis. You want to do test-driven development and run your automated tests on that code to make sure it's doing what it's supposed to do. You want humans to review the code and look at it and make sure that it's correct, right? Or AI, or both, right? But yeah, it's still a huge step up in productivity, even though, the different input might lead to, or the same input might lead to a different output the next time around.
Yeah, so it's so interesting the way people get kind of like mislead themselves when they're interacting with computers, right? And it's kind of like, these so-called AIs, they hallucinate and make mistakes all the time. When will they achieve human intelligence? And it's like, what are you talking? They just did. They hallucinate and make mistakes all the time.
Humans do that all the time. People confidently make those arguments to me on social media all the time, saying like, hey, these hallucinations are proofs that they can't do logic. I'm like, oh, really? Have you ever met a human that does logic perfectly? Because I haven't.
Well,
I've worked in software my entire life, and we're all like logic specialists.
No, and the idea, like for example, just when it comes to the concept of hallucination, like there was a famous case in New York where a lawyer used some AI tool, probably ChatGPT, to sort of write up whatever they needed to write up to present their case to the judge. And it's like, and then the people like, the AI hallucinated. Who was hallucinating? What did that guy think he was doing? What ideas did he have in his head for what he was doing, right? He was hallucinating about what...
And his hallucinating capabilities of the AI that didn't exist.
Exactly. Yeah. And it's, an analogy I use for that is like, someone got distracted for a second and killed 10 people. And then, because they were driving a car and looked at their phone, and people are like, well, what distracted them? And it's like, hold on a second, what were they doing that a second's distraction could cause this to happen? And there's just this weird category mistake that people make when it comes to sort of, as soon as computers get involved, they start making these sort of very basic mistakes. And like I just love that. And I'm like, this sort of like, we've got a lot of authors who've been writing really great books about AI and on Leanpub. And the one observation that keeps coming up over and over again is treat it like you're not interacting with a person, but think of it that way.
Yeah.
And that is, that's and that's why I sort of brought up your very important distinction about functional understanding early on. You're not interacting with a person, but think of it that way. And that's the best thing. That's, it's not a calculator.
It's not a calculator. It's not going to be deterministic. It's not going to be perfect every time. It is going to make mistakes, just like humans.
Just like so just moving on to the last part of the interview where we talk about the guest's work as an author. So you're publishing this book in progress. How do you approach writing your books? Do you, or let's say specifically this book, do you have time set aside on Saturday afternoons? Do you take time every day? Do you just kind of work on it kind of when you feel like it? How do you approach writing?
So I'm trying to get as much of it done as quickly as I can, because while I'm writing this book, I'm also bringing a new team up to speed on AI-driven development. I spent the last year getting them up to speed on test-driven development and functional programming, which are skills they're going to need to do really well with AI-driven development. And we spent a lot of time working towards continuous delivery and things like that. So the thing about AI-driven development is it's going to increase the output of the team by an order of magnitude per team member. So just imagine the explosion of code that's going to start coming out when they start using AI-driven development. If these engineers didn't have the proper training on test-driven development, on critical thinking, on functional programming, and on the basics of continuous delivery, that would create a problem. The same kind of problem that you would get if you tossed a whole bunch of junior developers into a project without enough direction and mentorship, right? They would be stashing time bombs all over the code base. So I spent the last year focusing on those other areas before I got to AI-driven development. And now that we're here working on AI-driven development, I need training materials for them. I need to make sure that there's a solid curriculum that they can learn from. So I'm working very hard on my nights and weekends and mornings and lunch breaks and afternoons after I got off work, basically as many off hours as I could spare to get this done as quickly as possible, because I need it to train people to do AI-driven development. So I think my approach is very pragmatic in its accelerated pace, right? So to give an example of that, I've been thinking about this book for the last year and a half, thinking about how I was going to do it and how I would structure it and things like that. And then, and I've spent quite a bit of time like exploring, like, how do I structure this narrative, and what are the topics that I need to address? And a lot of that time, AI-driven development was very nascent. It was in the very early stages of development. Like it didn't exist before March of last year in any real way, right? So I wanted to spend a year exploring it before I really dug into the book and started writing about it, because I want some level of expertise on the topic, right? And my 3 years before that, exploring GPT-3 without any real AI-driven development capabilities, like any real functional capabilities that we could apply to like large projects and accelerate workforce productivity, right? It's only been the last year and a half that this has been a real thing. So I wanted to have some level of experience with it before I actually wrote the book. And in that year, I've learned so much about AI-driven development. Like I've really packed a lot of learning into that tiny compressed space of a year. And like, if I could afford to, I would give it, 5 years, 10 years, become like a real like world-class expert on the subject. There aren't any world-class experts on the subject of AI-driven development yet, because it just hasn't been around long enough for that kind of expertise to sink in. But I don't have that kind of time. So I'm just cranking it out as fast as I can, try to share the knowledge and disseminate it with my team.
The last question I always like to ask in these interviews, if the guest is a Leanpub author, is if there's one thing that when you're using Leanpub has you shaking your fist going, damn you, Leanpub, this sucks so bad, or if there was one magic that we could fix for you, or if there was one magical feature, anything that you can think of that we could build for you, what would you ask us to fix or build?
What would I ask to fix or build? I would say you are already doing a lot of the things that I would ask you to do with Leanpub. The one thing that I would really love, though, is like a virtual me that can answer questions about the book, informed by retrieval augmented generation, trained on the book. All right. So things like that would be really cool, where the user could just come and ask and then say, hey, I am so-and-so, and here's my background. Is this a good book for me? And then the AI could answer. That would be cool.
That is very interesting. I will think about that and talk with Peter about that. That's a very good idea.
Maybe wait until the next version where they hallucinate a little bit less.
Right.
Because they do still hallucinate details that aren't true, and they might make things up that are not in the book. However, like that criticism is quickly fading because every new generation of model reduces the hallucination rate pretty significantly, except for the distilled models, which are like GPT-4o, for example, is a much smaller model than GPT-4, and it hallucinates a bit more, right?
Yeah, I mean, and just to add to that, and people are also learning, right? How to interact with it better. When mobile phones first came out, everybody walked around with them ringing everywhere all the time, and we learned that was dumb. Make it buzz, or don't answer the phone until later. People are learning. Oh yeah, these things hallucinate. Sometimes they say things that are false. You still need to use your own judgment, just like you should with everything you read,
just like you should with humans, right?
Yeah, Eric, thank you very much for taking some time out of your day to talk to me and to talk to our audience and everybody. And thank you very much for the great new book. It's The Art of Effortless Programming, Unleashing the Power of AI-Driven Development. It's going to be a really transformative book, and I really hope it's going to be as much of a bestseller as your previous book, Composing Software.
Thank you. That's my pleasure.